Today we're going to review for your test on the organization of the periodic table. So the first thing you should do is take some time to review the vocab, make sure you know what each one means and how it's used. Next we have some history of the periodic table. So Mendeleev organized the elements by their properties, and he tried to organize them by their masses, but that didn't always work. Moseley organized by atomic number and properties. So 1, 2, 3, 4, and then he made a new row when the properties started repeating, and that's how the periodic table is organized now, just with the addition of noble gases and lanthanides and some other elements. Periodic means regular repeating pattern, so there's lots of things periodic about the periodic table. Atomic number goes in order, mass goes mostly in order, valence electrons goes 1, 2, 3, 4, 5, 6, 7, 8, then repeats. Metals, metalloids, and nonmetals go in that order when you move left to right on the periodic table, and then it repeats. We spent a long time learning about the trends of the periodic table, about atomic radius, ionization energy, and electronegativity, so let's practice with a couple of problems. First problem, put in order of increasing atomic radius, cesium, iron, and fluorine. So let's go ahead and look at the periodic table. On the periodic table, size of elements goes bigger as you go down a group because elements have more electrons that fill higher energy levels. Size of elements gets smaller as you move left in a period because there's less protons to draw the electrons in, so electrons stay out farther, make the atoms bigger. So the size trend goes from helium down to fluorine, like this. So cesium, iron, and fluorine. Of cesium, iron, and fluorine. Fluorine is the smallest, iron is in between, and cesium is the biggest. Our next problem, put in order of decreasing ionization energy, neon, argon, and krypton. So let's take another look at our periodic table. Ionization energy gets bigger as we go up the periodic table because atoms get smaller. So the electrons are closer to the nucleus and more attracted and harder to remove. And ionization energy increases as we move to the right on the periodic table because, again, atoms get smaller because there's more protons. So for neon, argon, and krypton, ionization energy decreases as we move up that group. So krypton, argon, neon. Krypton, argon, neon. Our last problem for electronegativity, put in order of increasing electronegativity, aluminum, silicon, and oxygen. So let's look at our periodic table. Electronegativity follows the same trend as ionization energy, because as you move up, atoms get smaller, so electrons are more attracted when forming a compound. As you move to the right, atoms get smaller, so there is more attraction when forming a compound because there's more protons. So the order of increasing electronegativity would be aluminum, silicon, oxygen, which is the same order as what's given already. So moving on, we've already talked about explaining those trends. So if you're going up and down the periodic table, explain it with number of electrons and the energy levels they fill. Farther from the nucleus is bigger and less attracted. And if you're going left and right on the periodic table, explain with the number of protons. As you go to the right, there's more protons that draw the electrons in, so the atom is smaller and the electrons are more attracted. And the problems we just did were predicting relative atomic radii, ionization energies, and electronegativities. Groups contain atoms that have similar properties because they have the same number of valence electrons for each group. You can figure out the number of valence electrons that each element has by looking at its group number. So it goes 1 for group 1, 2 for group 2, The transition metals, groups 3 through 12, have varying numbers of valence electrons, 1 or 2, and then 13 is 3, 14 is 4, 15 5, 16 6, 17 7, 18 8 is 8. So the octet rule, noble gases are stable because they have 8 valence electrons that fills up their outer energy level. Predicting relative sizes and stabilities for ions, there's two things we need to look at, electrons and protons. For example, N-2 and N-3, which is most stable, N-2, N-3, which is a bigger ion. So again, we're going to look at both numbers of electrons and protons. So they both have 7 electrons because they're both nitrogen. N-2 has 9 electrons because it has a -2 charge. That means it has 2 extra electrons. Electrons are negative. N-3 would have 10 electrons. So for stability, pick the one that has the same number of electrons as a noble gas. So that would be N-3, 10 electrons like neon. For size, if they both have the same number of protons like this problem, pick the one that has more electrons, is bigger because electrons add to the outside of atom. If the electrons are the same, then the one that has less protons is bigger because it does not draw the electrons in more. So in this problem, N-3 because it has more electrons. Last for your test, learn the names of the regions of the periodic table. They're listed here for you, and you can see the nice color coding on the periodic table in your book. Hope this helped.